The more I research, the more I realize that we have more questions than answers. And if you've ever wondered what the universe is expanding into, there's a good chance you felt it too. That quiet discomfort mixed with astonishment, like something about it doesn't quite add up. So quite often, it's easier to shake it off and not worry about things like what space is expanding into. And if I'm honest, I wish I could do that. Just leave it alone and let others figure it out. But perhaps, like me, you enjoy the discomfort of sitting in the big questions, learning, knowing you may never know, and having no agenda, just love for this weird reality. Understandably, most people take comfort in the standard explanation. In many ways, I envy them. For this topic, they say, yes, space is expanding. But don't worry, not into anything. There's no edge, no outside, and maybe that's exactly right. But something feels off about it, because the deeper I looked, the more I realized something. There isn't just one way to think about this. There are dozens of serious models, some of them strange, some of them elegant, but all of them asking big questions about what space really is and where is it going. So today, we're going to explore them. Not all of them, not all in full depth, but just enough to open a door for perhaps you to explore more and hopefully create a dialogue in the comments so we can all learn as much as we can. What you're about to hear isn't just speculation. It is a collection of real research and perspectives across physics. Some of this fits neatly with the standard model. Some of it doesn't. But together, it paints a picture of a universe that's far stranger and more beautiful than we're usually told. So get comfortable and let's get into it. Before we tackle what space is expanding into, we need to lay down a minute of foundation. The standard explanation for cosmic expansion comes from general relativity, Einstein's theory of how gravity and space-time behave on the largest scales. In this view, the universe is not expanding into anything. It's not like a balloon inflating into empty air. It's more like the space between things is stretching everywhere, all at once. The galaxies aren't moving faster through space because of expansion. They are being carried apart because space itself is growing. In this model, the universe has no center, no edge, and no outside. It fits neatly with other conventional explanations, not just of expanding space, but of the broader cosmological picture. Light from distant galaxies appears stretched, what they call redshift, and that stretching increases with distance, just as expanding space predicts. The idea of a hot, dense beginning, the Big Bang, emerges naturally as the backdrop for this expansion, and the accelerating pace of that expansion is attributed to dark energy, a kind of pressure written into space-time itself. Within this framework, these observations all fit. They all reinforce each other, and they have helped shape the most widely accepted model of the cosmos. For over a century, this model has guided our understanding, from the birth of the universe to the motion of galaxies today. Most videos stop here. And honestly, they might be right, and in that case, the question is answered. But for me, and maybe for you, the real curiosity begins where the answers start to break down. And as you will see, many scientists believe they do. Due to the expansion of space, there's a limit to how far we can see. The observable universe is about 46 billion light-years in every direction. That number might seem strange, since the universe is only 13.8 billion years old. But the key is that space itself has been stretching while the light has been traveling. The farthest galaxies we can observe have been moving away the whole time. And if you want to understand how space itself can travel faster than light, check out the video we just did on that exact question. But in short, what we call the observable universe isn't the whole universe. Most conventional models suggest it's a small patch of something far larger, possibly infinite, or possibly curved back on itself in higher dimensions. But either way, we're left with a strange truth. What we can see may only be a sliver of what actually exists, and that sliver is getting smaller all the time. And what lies beyond the observable is where many of the big questions begin. Even though the standard model has shaped our understanding of the cosmos for decades and is the most widely known, there are tensions. They come up from inside the field itself. Physicists are working hard to refine the very models we've relied on, and I bet, like me, they too wish that this was the answer. Conventional, mainstream, easy. But still, many have questions that still have not found satisfying answers. A few on that list: why is space expanding? Why is that expansion accelerating? And more to the focus of this video, what is space expanding into, if anything at all? These aren't just questions from the sidelines. They are from the best of the best. And as you will see, not everyone agrees on where the answers might lead. Some believe our universe is part of a larger structure. Some think space might be a surface embedded in something higher. Others believe that space itself might not be fundamental at all. So let's explore some of these possibilities. If space is expanding, what is it expanding into? This is the question we're going to try to answer for each of these models. One of the few models that tries to answer this in a literal sense is called Brane Cosmology, from string theory and higher dimensional physics. In this view, our universe might be a kind of surface, a three-dimensional membrane, or called three-brane, embedded in a much larger, higher dimensional space called the bulk. The bulk is a hypothetical space with more dimensions than we can perceive, possibly 5, 10, or even more, within which branes like ours can float, bend, or collide. We live on that brane. Everything we experience, light, matter, even space itself, all exists on that surface. Imagine it like living on the skin of a soap bubble. You can move along the surface, but not off it. So when scientists say space is expanding in this model, they mean the surface of the brane is growing. Galaxies are spreading apart not because they're moving through space, but because the space itself, the brane's surface, is stretching. But what is beyond that surface? And could space be expanding into that? In Brane cosmology, the brane itself may be moving, bending, or even interacting with other branes in the higher dimensional bulk. In fact, one version of this theory, called the ekpyrotic model, suggests our universe began not with a singular bang, but with a collision between two branes. That impact in a space beyond our own created the hot, expanding cosmos we live in now. This model doesn't just shift how we think about the Big Bang, it also gives us something rare in modern physics, a literal outside to our universe. So whether or not this turns out to be true, Brane cosmology opens the door to a bold possibility that our entire universe is part of a much larger structure, and that space, rather than expanding into nothing, may be unfolding across the surface of something bigger. Another way physicists have tried to answer the question, what is space expanding into, is by zooming way out far beyond our own universe. In this view, what we call the universe might actually be just one bubble inside a much larger, inflating space. This is the idea behind eternal inflation, an extension of inflation theory, originally proposed to explain why the early universe looks so smooth and flat. But instead of inflation ending everywhere at once, eternal inflation suggests it only ends locally. Each time inflation slows in one region, a new bubble universe forms, and in between those bubbles, inflation continues, stretching space faster than light forever. Our universe is one of those bubbles, and in this model, space within our universe is expanding into the surrounding inflating background, a kind of high-energy space-time still undergoing rapid expansion. That background is sometimes called the false vacuum, and it's where new universes are still forming. But we're not expanding into those other universes. The bubbles are isolated by the ever-expanding space between them, pulled apart so fast they can never touch. So while eternal inflation offers a kind of structure, a cosmic foam of bubbling universes, our expansion still happens within our own bubble. And the bubble itself expands into a background that may have no edge, which raises a deeper question. What are we inflating into? In most models, it isn't. The background is either infinite or defined in such a way that it expands without needing to go anywhere. So while this model gives us a layered cosmic architecture, it doesn't ultimately solve the riddle. For some, eternal inflation offers a clean picture, a cosmic structure. For others, it just moves the mystery one level higher. One of the boldest answers in modern physics comes from something called ADS-CFT, short for Anti-de Sitter Conformal Field Theory Correspondence. But before we ask what space is expanding into, this model invites a deeper question. What is space, really? ADS-CFT began as a breakthrough in string theory. It proposed that everything happening inside a space with gravity, like a universe, might actually be described by a theory without gravity on a lower dimensional boundary. In other words, our universe might be a hologram, a 3D world emerging from information encoded on a 2D surface. This idea has been tested in very specific kinds of spaces, especially anti-de Sitter space, which is highly curved, but even so, many physicists believe the core principle could still apply. So what does that mean for expansion? In a holographic model, space isn't a fabric that stretches or balloons. It doesn't expand into anything. It emerges mathematically and physically from something more fundamental. And as the quantum information on that hidden surface changes, what we perceive as space can grow, evolve, or even stretch without ever pushing into an outside. In this view, asking what space is expanding into might be like asking what the surface of a hologram expands into, because space itself may be an illusion, projected from something deeper, not surrounded by something beyond. And that turns the whole question inside out. Instead of us looking for what lies outside space, we might need to ask what lies beneath it. Some of the boldest physics today suggest that space is not fundamental. It's something that emerges from the quantum world, built not from stuff, but from relationships. In these models, what we call space comes from entanglement, the invisible link between particles that share quantum information. The more entangled two regions are, the closer they appear in the geometry of space. It may sound abstract, but it's backed by serious mathematics. Researchers have shown that space-time itself can arise from patterns of entanglement. In some simulations, when researchers reduce the entanglement between two regions, the space between them shrinks or even disappears entirely. Now that might sound strange, but it reveals something profound. Space doesn't exist independently. It's held open by relationships. So what does it mean when we say that space is expanding? In this view, it means that those quantum relationships are increasing. More systems are becoming entangled. More correlations are forming between distant parts of the universe. As the web of entanglement becomes more complex, the structure of space itself grows, not because it's pushing outward into something else, but because it's being built from within. Instead of stretching like a sheet, space assembles itself from shifting quantum connections. And if that's true, then asking what is space expanding into might be the wrong kind of question. There is no outside, because space isn't a container here. It's a kind of quantum scaffolding, a map of how things relate, not where they are. It means the structure of the universe might be made not of particles and forces, but of information. Space wouldn't just be shaped by what's in it. It would be shaped by what's between things. If space is built from entanglement, maybe it isn't smooth and continuous at all. Maybe space is a kind of network woven from discrete pieces of information. Several models in quantum gravity explore this possibility. One approach, called causal set theory, suggests that space-time isn't a flowing fabric, but a growing web of events, like nodes on a graph connected by cause and effect. Another model, loop quantum gravity, imagines spaces as a kind of spin network, a structure made of quantized units of area and volume, where geometry itself is fundamentally granular. In both views, space isn't made of anything within it. It's made from the way its parts relate. Its structure comes from connection, not content. So what does expansion mean in this framework? It means the network is growing. New events are being added. New links are forming between nodes. From a bird's eye view, space isn't stretching over a background. It's accumulating structure. The universe gets bigger because more of the underlying code is being written. And once again, there's no outside. Space doesn't expand into something else. It expands because there is more space. It's a subtle but radical shift. Expansion doesn't require motion. It only here requires becoming. Not all physicists agree that the universe is expanding forever. Some believe it has a rhythm, a cycle, and one of the most intriguing versions of that idea comes from Nobel Prize-winning physicist Roger Penrose. His theory is called Conformal Cyclic Cosmology, or CCC, and it offers a bold alternative to the idea of a universe that expands endlessly into nothing. In this model, the universe goes through aeons, cosmic epochs with a beginning and an end. Each aeon starts with a hot, dense state, something like the Big Bang, and ends in a cold, empty one, after all matter has decayed and even black holes have evaporated. But here's the twist. As the universe empties out, it becomes conformally invariant, a mathematical condition where scales no longer matter. There's no longer any meaningful difference between big and small, fast and slow. And when that happens, the end of one aeon can connect smoothly to the beginning of the next. There's no bounce, no collapse, just a kind of erasure, a scale that allows the universe to reset, as if the far future becomes indistinguishable from a new Big Bang. So what does this mean for the question, what is space expanding into? In Penrose's model, it's not expanding into anything. Instead, space is part of a repeating structure, one where time itself is cyclical, and every expansion eventually becomes a new beginning. There's no need for an outside, just an endless procession of universes. each born from the ashes of the last. Whether CCC is correct is still unknown, but it offers something rare, a vision of the cosmos where the mystery of expansion isn't pushed outward, but turned inward into the geometry of time itself. So when I first asked, what is space expanding into, I couldn't shake the feeling that something about it felt off. Not because it's a bad question, not because there aren't potential answers out there, but it seems that every attempt to answer it twists itself into a paradox. Over and over, though, one idea kept surfacing, that space might not be a thing in the universe, but something that emerges with it. And that's hard to hold on to. Our minds want something outside to expand into, a boundary, a backdrop, an edge. Maybe that instinct makes sense. In everyday life, everything we experience feels shaped by its limits. A cup by what's outside it, a sound by its silence, even a self by what it is not. But many of the models we've explored don't offer that kind of contrast. There's no other side of space, no hidden realm it's spilling into. So maybe the real mystery isn't where space is going, but what gives rise to it at all. Because space in many of these models isn't stretching like a fabric, it's assembling inward, woven from shifting relationships, entangled information, causal links, or geometric quanta. A pattern more than a place, a scaffolding of becoming, not just being. That quiet discomfort we feel at the edge of these ideas, it might be the first clue. A signal that we're reaching for something our current language was never built to describe. A way to name something we've never fully seen and may never understand. And maybe that's where wonder lives, not in what we already understand, but in the questions we can't yet answer. It's in the soft boundary between what is known and what is just starting to take shape. So if you made it this far, I hope you'll keep going with us here. I'd love to know what this stirred up for you. What do you think space is? What do you think about these theories? And most importantly, until next time, take care.